Today we will see in detail the example 4.5 of Griffith third edition Introduction to Quantum Mechanics. The example 4.5 is consider the case of two spin-off particles, say electron and proton, in the ground state of hydrogen. Each can have spin up or spin down. So there are four possibilities in all. These are the four possibilities. Here the right hand side is we have separated. In the left hand side we have the get S M, total S, total M. In the right hand side we have considered two particles. So spin of S1 and spin of S2 and spin of M1 and M2. Here you can see the M value is 1, that is both are in up, M1 is up, M2 is up. Here you can see there are two M0. One is the M1 is up and the M2 is down. Then another one is M1 is down and M2 is up. Third one, of course, both are down. This is both are up. I am referring only the M1 and M2. Here, both are down. This can be written as linear combination. We are going to see it right now. In our example, we have seen four state and m equal to 0 for two state. Just now we have seen. In one case, it is spin up and spin down, and the other case as spin down and spin up. This can be written as a linear combination because m value is 0. You can write this as 1 over square root 2 get spin up, spin down plus spin down, spin up. Now we have to see the eigenvalue. Let us say if operator is L squared, which we have seen already theoretically in my earlier lecture, addition of angular momentum, for which this eigenvalue is L into L plus 1 H cross square. Same is valid for J squared also, total angular momentum. I have discussed in my theoretical lecture, which is equal to J into J plus 1 H cross square. So same is valid for S squared operator also. Eigenvalue of S squared operator is S into S plus 1 multiplied by H cross square, because all comes under Lie group. So in any operator is in the Lie group, same rules are applicable equally for all the operator because it comes under Lie group. Now we will see what will happen if S squared act on get 1 1. So this S squared, actually S squared I will explain like this. Here I have mentioned red color one as electron, blue color as proton. Both are upstate. So this S squared is nothing but S1 per electron and S2 per proton whole square. This can be written as S1 squared plus S2 squared plus 2 S1 S2. This is possible only if S1 and S2 commute. Naturally, the S1 and S2 commute. So this can be expanded as this 2 S1 S2 can be expanded as 2 times Sx1 Sx2 because it has a 3 component inter, and Sy1 Sy2 plus Sz1 multiplied by Hz2, which act on spin up state of electron and proton. Now S1 square will not affect the state. It will gives rise to the eigenvalue. What is that eigenvalue? This eigenvalue is s into s plus 1, because this will act only on electron. First one is electron. So electron spin is off. So naturally s into s plus 1, s is off. Then s plus 1, 1 plus half is 3 by 2 H cross square, which is equal to 3 by 4 H cross square. So this is for s plus s1 square, s1 whole square. Same is the case for s2 whole square. This will act only on proton. So the spin of the proton is off. So same rule is applicable. Off plus s into s plus 1, off into 3 by 2 H cross square. So same, you will get 3 by 4 H cross square. Now we have to find this Sx into Sx, Sy into Sy, Hz into Hz. We will see first what will happen if Sx of 1 and Sx of 2 act on electron and proton. So first one is when Sx act on the electron, because this is for electron, you will get the eigenvalue, that is Sx matrix is this one. This is Sx matrix, which is equal to H cross over 2. We have studied it in Pauli spin matrices. H cross by 2, 0, 1, 1, 0. And you have to multiply this by a spin up state. Spin up state is represented as column matrix 1, 0. You know very well this. And similarly for proton. Proton also the Sx matrix is 0, 1, 1, 0, and this is of course H cross over 2, and this is a spin up state, that is 1, 0. What will happen if you multiply 0, 1, 1, 0, this row and this column, you will get 0. So I have written that as 0. Then second row, first column, you will get 1. So I am writing this as 1. So H cross over 2 is there. Same is the case for if I multiply these two matrices. So H cross over 2, 0, 1. See, 0, 1 represents the spin down. So H cross 2 into H cross 2, you will get H cross squared over 4. Spin down, port will come to down. So it will change the status of the spin. So we will see similarly the in the case of YY, what will happen. Similarly, what will happen if SY1 and SY2 act on the up state? So this is electron, red color electron. So the Pauli is matrices SY is this one. That is H cross over 2, 0 minus I 0, and it acts on spin up state, that is 1, 0 column matrix. Similarly the SY2 for second one, same, the Pauli matrices are same. SY is this one, and the spin up state, which act on spin up state. Now you multiply the first row and first column, you will get 0. So you will get 0. First row, second row, first column, you will get I. So that I am bringing out outside the matrix. That is H cross by 2 will become I H cross by 2. You do the same thing here, you will get same thing, I H cross over 2, 0, 1. See here, spin up state 1, 0, 1, 0 will become 0, 1, 0, 1, spin down state. If you multiply I H cross, you will get minus H cross squared, and 2 into 2, 4. You will get minus H cross squared over 4, of course spin down down. So and similarly what will happen if sz act on sz1 and the sz2 act on the spin up state. So the Pauli matrices sz is equal to that is h cross over 2 1 0 0 minus 1. So which act on spin up state, that is 1 0 column matrix. Similarly HZ2 which act on this proton, 1 is per electron, 2 is per proton. So same matrix element, that is h cross over 2 1 0 0 minus 1 HZ matrix. So these two matrix act on spin up state, that is 1 0 1 0. If you multiply first row and first column, you will get 1. Second row, first column 0. So this will become h cross over 2 1 0. Similarly same thing, h cross over 2 1 0. So both are spin up state only. It retains the state. Unlike SH and SY operator, SZ operator retain its state. So this will become h cross squared over 4 spin up and spin up. Now what is S square act on spin up spin up? We got for S1 S1 squared 3 by 4 h cross squared spin up because S squared operator will not affect the matrix. We have seen, sorry, affect the eigenvalue. This is S1 squared for S1 squared. So this is for S2 squared. Same value will get 3 by 4 h cross squared. We have seen just now 3 by 4 h cross squared, both up and up. Then here for SX matrix, 2 times we have to add 2 times. This is XX. When SX act on it, we have seen this is h cross squared over 4. Both spin flip, that is upward spin will become downward. Then this is for SY. When SY act on it, we have seen minus h cross squared over 4. Minus h cross squared over 4 spin down and spin down. Then SZ act on it. SZ act on this. You will get plus h cross squared over 4 spin up and spin up. Here you can see carefully, maybe I will erase this in order to have better clarity. I can erase this. You can see here the first two term will get cancelled. So that is h cross squared over 4, h cross squared over 4. Not only that, because of same value h cross squared 4, it is the same state, down spin down state, so that we can cancel. Otherwise you cannot cancel. This will be 0. Then if you add first two term, you will get 3 by 2 h cross squared. So remember that both are up, and this term also up. Only thing is, if you multiply this by 2, you will get h cross squared over 2. So 1 over 2 h cross squared. All these three terms are spin up and up. You will get, when S squared act on spin up and spin up state, you will get eigenvalue 2 h cross squared spin up state. So same thing, you can use Lie algebra. S squared eigenvalue, when S squared act on it, just we have seen, when S squared act on the get vector, then eigenvalue is S into S plus 1. So here S is 1. So 1 plus 1 is 2. 1 into 2. S squared is equal to 2 actually. Sorry, S into S1 h cross squared. You will get h cross squared. So h cross squared, which is equal to 2 H cross square. That's what we got here. 2 H cross square, both state are up. Now we will see what will happen if lowering operator S minus act on spin up state. This is for lowering operator for electron, and blue color one is lowering operator for proton. So first you take the S1 lowering operator for electron. So red color one. Red color one naturally it will become H cross, that is S minus matrix. This is lowering matrix S minus will act on the spin up state 1 0. Then what will happen if it act on the proton? Nothing. Proton, this cannot act on proton because this is for electron operator. So proton I am keeping as it is. Next I will take this S sub minus 2 operator. So it will act only on the blue color proton, which is spin up. So that matrix I have written, that is S minus. I am keeping this spin up electron as it is. Here I have kept the spin up the proton as it is. Here spin up the electron. Then S minus matrix is stitched, and the spin up state is 1 0. What will happen now? You multiply this first row or first column 0. So second row or first column is, this will become 0 1. That is spin down. So this can be represented as H cross spin down. Red color will go to spin down, and blue color I am keeping as it is. In the second one I am keeping red as it is because I S sub minus 2 act on it. So it will act only on proton. So red color as it is spin up, blue color spin down. Because if I multiply this and this, I will get like here I will get 0 1 matrix, that is spin down. So I can multiply and divide by square root of 2. So 1 over square root 2 is normalization constant. Then this will become spin down spin up plus spin up spin down. So the S minus operator act on spin up state is that is S is equal to 1. There is no change in S, but M I can take. Now you consider S is equal to 1, M equal to 1 and 0. If S is equal to 1, 1 into 1 plus 1, 2, this will become 2. And when M equal to 1, this will be 0. 1 minus 1 is 0. If M is 0, this will be 0. So this will be always 0. You can ignore. So I will get square root of 2 H cross, and this energy state 1 over square root 2, which is a normalization constant, spin down spin up plus spin up spin down, exactly what we got from this matrix multiplication. I got using this Klipsch-Gordon coefficient. Please refer my lecture on angular momentum. Then next let us take this as our initial state, that is 1 over square root 2 down up down. What will happen if S minus lowering operator act on it? So if lowering operator act on it, this is the red color is lowering operator for electron, blue color is lowering operator for proton. So you take first one. The red color is already in spin down state. You cannot bring still down. So this will become 0 when it act first. Then if it is act as in the second second combination, then it will come to spin down. So spin down with this, as I said here, the with eigenvalue H cross. So here I will have red down and blue also down. And then let the S minus lowering operator for proton act on it. So it is in the up state. So naturally this will become down. So red down, this blue also down. What will happen if it act on the second one? Second one already blue is down, so this will be 0. So finally we got 1 over square root of 2 H cross down down plus H cross down down. So now you can take H cross plus, you can add this. See here you cannot add. I have not added this. I have taken only H cross outside because both are different state. So here both are down 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 same state. I can take H cross plus H cross, which will become 2H cross. So 2H H cross 2 divided by square root 2, I will get the square root of 2H cross. Both will get down down. So about the triplet state, we have seen when S squared act on spin up and spin up, I will get the eigenvalue of 2H cross squared spin up, which is the first one. Then this linear combination 1 over square root 2 down up plus up down. So I will get 1 0. This is the that is S is equal to 1, M equal to 0. So this state I got when the lowering operator act on spin up and spin up state. I will get this one, second one, with an eigenvalue square root of 2H cross. This is the another state, state 2. And we got when S minus act on 1 over square root 2, this combination spin down, spin up plus spin up, spin down, I will get square root of 2 H cross spin down, down. That is the next one. So both spin are down, then it is equal to S equal to 1, M equal to minus 1. In this case, both are 1. S is equal to, sorry, I will come to it. So yes, here in this case, S also equal to 1 and M also 1. Here in this case, we have S is equal to 1, M equal to 0. Also, so M equal to, S is equal to 1, M equal to 0. We got this state. So we got this state, all the three triplet state. Now we will go for singlet state. Now we will go for singlet state. Singlet state. Singlet state. You apply the same method adopted for triplet. So for singlet state, get 0 0 can be written as 1 over square root 2 linear combination of down up minus up down. This red color is for electron and blue color is for proton. So when S squared act on this, get 0 0, it can be expanded. This S squared, as we have done just now, is S1 whole squared, S2 whole squared plus 2S1 S2, which will act on this vector. So this 2S1 S2 can be written as Sx as usual, Sx1 Sx2 Sy1 Sy2 plus Hz1 Hz2, which act on this get vector. That is down up minus up down. So first we will take this S1 squared. If S1 squared act on when S1 squared act on this get back this vector, then you will get 3 by 4 H cross squared, as we have seen. and s1 squared also. This it will not change the state. S squared operator will not change the state of the system. So this will become 3 by 4 h cross squared, 3 by 4 h cross squared. So which if you add these two, you will get 3 by 2 h cross squared. So you remember that this is 3 by 2 h cross squared. Then we have to find this value. What will happen when Sx act on this combination? You know, this can be written as 1 over 4 h cross squared, as we have seen earlier. This is 1 over 4 h cross squared, and this state get flipped, that is up down, and minus 1 over 4 h cross squared down up. So this can be written as 1 over 4 h cross squared outside, then this state alone, up down minus down up. But actually what is here, this operator act on this down up minus up down. This is just inverse. So you take negative sign outside, then this will become plus and this will become minus. So I will get this as a spin down, spin up, minus spin up, spin down. So exactly same as this one. So I have introduced this minus here, minus 1 over 4 h cross squared, 1 over square root 2. Similarly for sy1, sy2, when it act on 1 over square root 2, spin down, spin up, minus spin up, spin down, I will get minus 1 over 4 h cross squared. Of course, this is same thing. Similarly, for sz, I will get minus 1 over 4 h cross squared. So I can replace this minus 1 over h cross squared over 4. This h cross squared over 4. This is also h cross squared over 4. And I will get, if I add this 4, 3 term, then I will get 3 divided by 4 h cross squared. Already there is 2 here, so 2 will get cancelled. This is minus, of course, minus. So here I have plus 3 by 2 h cross squared. Here I have minus 3 by 2 h cross squared here, because this 4 cancelled with this 2. So 3 by 2 minus 3 by 2 h cross squared. So which will become 0. So this is about the singlet state. Thank you very much for watching my video and supporting me continuously. Thank you very much.